physics video, graph science and such, magnetism and induction, electricity, and how they're manifested out of this quantum stuff, this gravity field. And yeah, so it's no doubt going to make mistakes. I'm just working through this in terms of trying to get a description of it myself that's, more accurate and concise. So in theory, I'm sort of in theory arguing that I think the universe isn't, it's all these little arrows. So let's just real quickly draw little arrow thingies, going in all kinds of directions, complete balance in terms of these little BBs. And the idea is that they end up in matter, which is a consolidation of them, where they are in sufficient volume, where they essentially have positions that maintain an order. This condition is maintained over a period of time where the predominance of the structure will be this structure. So when you net out all the movements, that's the movement you get as the net product of, forward, back, sideways, all this stuff. If you average it out, this position averages this position averages that. But essentially, for the sake of just understanding it, it's an orbit. It's the chaos trapped in an orbit, but it's really the same chaos. The chaos never changes. All that changes is this idea of polarization. So that's where you get into this magnetic effect. And it's like light. Light is gravity that has a frequency. Now, it's not some extra stuff. It's just that this bit of stuff now has been polarized in such a way, and like we have something that's called unpolarized light, but what it is really is mixed polarization. Each piece of light that's part of something you're seeing, each piece is polarized, but they're polarized in opposite directions. So you end up with a mixture. So the gravity is polarized in the sense that each bit of the universe has an identity of polarization, but it's all mixed. So there's a difference between a stream that's mixed and a stream that's not. And so polarization, like direction, is exchanged, but it's also just something that can be created. So at any point, this mechanism can polarize these bits, so they can be without any energy loss, without any difference being noticed. There'll be some percentages, like I said, so some you can just think of it as, this way versus blue, let's say, being this way, and that's polarization, is this shape. So it's just the difference between being up and down and being left to right. And those are your two versions. And you could just say that one has a zero. Well, let's not get into that. But what you would be doing when you're changing something in the universe, as I've stated, the interactions look like something's happening. Two things go in and two things come out. But, in theory, you can see it either way. This just goes straight through, or this goes straight through, or you can see that something is completely changed in its direction. But the end result is nothing. It is as a practical matter understandable that nothing changed. That, as a fact. Okay, it's paradoxical to say, but obviously something changed, but nothing changed. Okay, that doesn't. So that's the kind of language I have to fix. There has to be some way to describe this circumstance where the change is meaningful, because the change carries with it this idea that you could through these interactions, create a scenario where all the stuff that just happens to be going in one direction at one point has all the same polarization. So you can exchange polarization. You can change the polarization. So this could be polarized red, and this could be polarized blue, and that would change the identity of this interaction. Then it would be a straight through interaction for the polarization. So anyway, back to the light. So light's migration through this field of chaos that just has a frequency of identity, a distance between the bits. And so I don't know whether to say that's structural or just because there could be alternately polarized bits in between, but they won't be noticed. So theoretically, this frequency could just be a matter of which ones are properly polarized within that stream of quanta that's, and everywhere there's a stream of them. And it's just this particular stream has pieces of it that are polarized at a specific frequency. So this theoretically, this could be, the real quanta could be so tightly together that it's, there's tens of thousands of them, and a frequency of very like ultraviolet light could just be this distance here. These two here are polarized, and therefore they'll be recognized by an electron when they hit it. The electron will only see these polarized, the ones polarized up and down. It won't see the ones not polarized up and down. So you could still have a condition where something's just riding on the condition. So you have this randomness is still existing in the field, and what's changing in the field is which part of the randomness is where its polarization is. All right. Again, I don't know how, this isn't like critical to the fundamental point that energy, matter, all this stuff is made out of this quanta, these little BBs moving. And that they are indestructible, and you can't really change their direction. Again, you can only change identity, a position's identity, not a thing's. Like I said, this is still, this will always continue. There's no, you can't stop any of it. Gravity, electricity, it all is stuff that was going to go that way anyway. And what makes it meaningful is its polarization. What makes it noticeable, what makes it have an effect, is how it's polarized. Is it will affect electrons' polarization and the atom's polarizations. You see, it weeds all the way down to sensitivity to this polarization. All right. So I was thinking about conductors. So you just say if you have just a straight wire and plus and minus, or minus and plus, it doesn't really matter. There's an actual thing going through here. These are little quantas that are flying through this wire. It's actual energy. It has actual mass. It's an actual substance that's going through the wire. It's not nothing. It's a something that's going from one end of the wire to the other end of the wire. And what's really happening to the wire is it's changed its polarization when it has electricity going through it, when it has a current, a potential. Yeah, potential is all it really needs. So anyway, the idea would be is that things that are polarized, let's say this way, we'll call 0, and things polarized this way we would call 2. So it's the same. When you add it up, it's still 1 and 1. 1 plus 1 equals 2, and now it's just that in terms of effect, polarization has this effect that you can be either sensitive to one, polarization this way direction, then this would be the 2. And if you were sensitive to polarization in this way, this would be the 2 in terms of the math. But the idea is it's all or nothing now. If it's a polarization you like, it has a double effect of gravity. And if it's the polarization you ignore, then it has no effect. It's like the gravity didn't exist. But you can sort of understand that it would add up to be the same thing if you can't completely be uneven in your receptiveness to polarization. So that's why there's no, in nature, even in man-made creations, there's no such thing as a monopole. They haven't found something that has a plus but no minus, or a minus with no plus. And because it still has to add up to a 2. You still have to have 1 plus 1 in there somewhere. You have to have the 2 come out somewhere. You can't just have all 0. And you can't have all 2. Because that would make you twice as vulnerable to gravity. You have to be stuck to this other half that has the 0 effect. So, yeah, this is really, it's not that the idea is complex, but it's complex in terms of describing it. So the idea would be, as a typical magnet, this side would be sensitive to polarization, and this side would have no effect on this in terms of making it of it absorbing it or being able to create acceleration. It can't absorb it, so it can't be accelerated by it. But you could see that the way gravity works, that it's always going to add up to the same amount. There's going to be 0 here, but twice as much here, so the net effect is still going to be as if it's the same weight. It's not going to change its weight in gravity because it's exactly the same reaction. And the gravity, you have to understand, that's coming down is of mixed polarization. So the gravity coming down has an equal balance of polarization. So each section is going to be hit by the part that it's a number 2 to. So this side is twice as vulnerable to blue, let's say, and this other side is twice as responsive to red, and vice versa, in terms of this one ignores blue and this one is twice as affected by blue. It ignores red, so reciprocal. This one has a 0 effect to blue, this one has a 0 effect to red, this one has double effect to blue, this one has double effect to red. So you can see that gravitationally it's going to be irrelevant. It's going to seem like exactly the same substance. There's no difference in this substance. The key is what happens when this gravity goes through. So it comes in mixed, but when it goes through the magnet, what's going to happen is the polarization is going to be all one thing. So it goes through it's sensitive to the blue, and it's going to release the red. So everything that comes out of this side of the magnet will be red, and everything that comes out of this side of the magnet, in terms of, this is just gravity that goes right through everything, so it's not like it's something different. It's gravity. It's just that the gravity comes out now polarized from a magnet. So, and so this obviously doesn't, it's all straight lines. So, obviously you have to add in all the angles that would happen, and so there'd be parts of where it gets polarized and then it gets repolarized the other, But the point is that everything that comes out of this surface would be blue, and everything that comes out of this surface would be red. And so it's about how you affect something else. So again, it's like the gravity argument. What I'm doing gravitationally and what the Earth is doing gravitational, although the two things have an effect on the end result, me falling, the two forces have nothing to do with each other. They're completely independently created. The Earth's gravity is the Earth's gravity, and my gravity is my gravity. What I'm blocking is what I'm blocking. The shadow I'm making is my shadow. The shadow the Earth is making is its shadow, and the two aren't mixing in any practical way, any real way. So what this creates doesn't have anything to do with what it does. So let's say you have this conductor, you can have a conducting metal, And what it's doing is a little different in the sense that, unlike the magnet, where it's sensitive to polarization, that is, it'll be twice as affected in terms of absorbing it. You know, if something comes in, it grabs it and it's accelerated by it. A conductor is not accelerated, generally speaking, by polarization. So you can hold a magnet next to a conductor like copper and it won't do anything to the copper. The copper won't move. It won't gain any acceleration because it doesn't recognize the polarization until you put a current in it. So there's things that are like steel, iron. So you have a piece of iron, and what it is it's sensitive. It's feeling the pressure. So when it recognizes polarization in the sense that it feels the double power. It has the built inside of it. Each little bit is a receptor to polarization, and it is recognizing the two thing. Okay, it's how to say this. Yeah, well, it's another induction argument though. So maybe what the point I'm trying to get to is there's two different parts here. The first part is the first component is being affected by polarization. The second part is creating polarization. So again, the point is the magnet does both, but some conductors can do just one of those things. So if you pass electricity through a wire, what you're really doing is turning it into a producer of polarization. So now when the mixed polarization comes in, this is kind of tedious, right? Yeah, I gotta put the little red shit in, and yeah. So the mixed polarization comes in when there's current in the wire, and what's coming out is one polarization. Again, you know, it ends up being polarized, which means that it is separating the polarization. So it will become a magnet, essentially. And now, depending on how you turn that piece of wire, so if you give it, so you can sort of think about it just as putting a bend in a wire, that you've automatically created a directional change. You know, the stuff is moving this way, and now it has to exchange its vector for this way. So now we're back to this argument. So there's an exchange, and then there's another exchange in direction down here, and then there's another exchange in direction here. So those exchanges in direction that are the points where the polarization is established, let's say. So anyway, so when you have a coil of wire and you're passing electricity through it, what you're really doing is just expanding the amount. Obviously with each amount of wire, you're blocking more gravity in the sense that it's hitting more stuff per square inch, and so you're creating more polarized gravity coming out. I mean, you're just putting more stuff in the way of the field, and so there's more stuff coming out in the end. So you're increasing its magnetic, what it's producing as an effect. So the effect is that gravity comes in unpolarized, mixed, and it comes out polarized. But the wire itself is only weakly affected because it doesn't have much mass to it. So it doesn't gain much magnetic acceleration. Okay. Yeah, it's just, it really is, it's complicated. So I still want to try to find some way to explain this idea that it's this channeling, shaping, no, it's the wrong word, pattern. It's just creating a pattern. It's just reconfiguring the identity. Identity isn't a great word either, but I suppose it'll have to do. Um, and by doing that and creating this idea of the sensitivity to it, that you create the movement. So you can sort of understand, I think, is if I have another magnet down here, now that I have changed this field, okay, the gravity's now coming in polarized, and if I'm polarized the opposite way, the two sides are exactly the opposite of what the other thing was in terms of the sensitivity. That the very thing I'm, insensitive to now is going to be coming to these two sides. So I'm going to be getting a preponderance of the stuff hitting here is going to be the stuff I have zero interest in, and the stuff hitting this one is going to be the stuff I have zero interest in. And so now this external gravitational field, that's mixed still, so it has an effect on both of these sides, is going to end up pushing this into this. And you have to understand that what's coming out of here is exactly the same as before. Well, this side is the blue, so I'm sending out the very thing. So when this side filters, it sends out the very thing. This thing has zero effect, and this side will be sending out the red, which will be exactly this side's zero effect. So you can sort of get the idea of what attraction is made out of, which is the absence. In here you end up with a zero. So that's why magnetism appears so strong, is it's completely negating the existence of gravity in between the two things. It's zeroing all this, the gravity is being zeroed out in between these two things. So there's no gravitational force going this way anymore. Obviously still some is coming in this way. That's why it's not an unovercomable force. It's strong, but not incredibly strong. It's because there's still plenty of leakage coming in through the sides. But it's a strong force because the field gravity is still hitting this thing and moving it in this other direction. It's still applying the pressure. So you could say it's twice as strong as what its real gravity would be in some sort of universal field, space or something. Some space where there's nothing else gravitationally influencing something of the same mass. It would have a potential to gain a certain acceleration equal to whatever the other size of the magnet is. So, if you just had two equally sized magnets, they would have it's not even a good way to say it. Anyway, it's a much stronger effect than gravity normally. But the opposite would be true. So if I switch this magnet, reverse the poles, you can understand that that's the nature of repulsion, is that I've now doubled the force. I now have the two effect on both sides. So I have twice the strength of the gravitational field influence. So the part that is too sensitive and sensitive are both pure, and so then now there's going to be twice as much, technically, a kind of twice as much gravity in here that there is out here. So there's going to be this repulsion force that'll push the two things away. I think that description of magnetism is understandable, but really what I wanted to get to was the idea of what's happening with the wire that enables it to create this same effect. And that's where things get a little more complicated. So what has to be happening? So with a wire, if just flip the paper over, that'll work. Somehow the conductor has to be changed into something that is like a magnet, polarized. So there has to, it has to create these two poles, and that the one side is one now sensitive to the other side. And what I think has to be happening is that the current has to wrap around the conductor, in a sense that it has to switch which side, which surface it's stronger on. But part of that doesn't make a ton of sense, just because we already know that a conductor, let's just say it's round, going this way, that the field, the idea is that the polarization is from the interior to the surface, and the entire surface is these electrons. And so the idea that a bare wire, a straight wire, somehow is still creating enough of a field to, say, move a compass. Yeah, I don't have a huge, just thinking about it, like I said, I wasn't considering the fact that somehow I need to have a plus and a minus end to the conductor to create that effect. But what's really happening is, well, in that, it doesn't matter what's really happening. I mean, even if I said it's only happening on an atomic level, like all the little atoms are lining up one way on this side and they're all lining up the other way on this side, you still have to explain that collimative effect and how that's transmitted through the conductor. So obviously it has to be transmitted from one side to the other. Like the idea of it has to, push from the ends, or where its primary exists. Like there's too much plus here and it migrates this way, and there's too much negative here and it migrates that way. In terms of there's more of the electrons at one end than the other. And there sort of are. I mean, there's always places where the voltage is higher, and that you're more likely to be able to create a spark gap, let's say. So there's all kinds of rules about surface area and how that's manifests. So I should really probably think about that. But it probably has something to do with how the current is transmitted across the conductor. I mean, I just want to get to the point that the idea is that the gravity comes when when a conductor has no voltage in it, it's not changing the gravity. So it just remains a mixture of polarization. And then when, so the same thing is happening out here. So, it comes in mixed and it goes out mixed. And what's happening is when you put a current through it, when you charge it with an electric potential, then this is now being polarized. And so, the reds are now blue and these blues are now red. And, that's the difference. And the explanation for that, like I said, it would be easier to explain. Yeah. If it was coiled, because then you can see how the field has, some of the field ends up going through two conductors. It goes through the one here and it goes through the one on the other side of the coil. So as they're coiled this way, there's corruption between these different fields. That you could say that, yeah, first it's polarized red and then it's polarized back to blue again, but it's always polarized by every transmission through. It only comes out one way, it doesn't come out mixed, is the point. So yeah, I have to think on that one. So that's a place to be fixed, is how the current moving through the wire, even though it's, let's say it's, just trying to think if it's a charged battery and a wire. I'm just trying to think if there's any way to charge a conductor without running current through it. And you basically have to have the current moving through it. So it's the movement of the current through the wire. And the idea of that movement is that it's exchanging polarization as it goes through. So it's polarized current is intrinsically polarized, and as it goes through the conductor, it's forcing polarization on the stuff coming out. So that means that it's the stuff that is polarized a certain way here, it's letting it passes through, and then there's a point where it reverses. And I just had a thought about why it would do that. But see, this is always happening with gravity. As gravity moves through you, it's making real exchanges. When you have velocity, let's say you're free falling, so you're actually gaining, you're accelerating, and so you're absorbing, in a sense, direction, because your velocity is increasing. So as your velocity increases, you're gaining these arrows in a direction. So your structure's changing. So instead of your structure being that nice little box, your structure becomes a box in a theoretical direction. Like I said, it's this idea that you're moving more this way than you're moving this way, and so you move in that direction because you have more arrows, more potential, more of the locations inside of you. You just thought of them as places around a clock, and there's a zillion clocks inside of you, and they're all little clock locations. More of the locations on that clock end up being in a direction. As you're gaining velocity, so you're taking from the field those kind of arrows as positions, and to do that you'd have to be releasing arrows in some other, more of them in some other direction. But that's a sort of a different subject. But it sort of has to do with this idea that we have a current moving, and so the current is the important thing, this polarized current. And the current itself only has an identity in terms of a direction. And somehow that direction, from here to here, goes through a process where at one point it releases, the red arrows. In terms of its interactions, it creates this red, the polarization this way, and then it somehow runs out. It somehow has to change to polarization this way, and I have to think of a cause for that. Yeah, because I don't have one right now, that's for sure. But it could have to do with this rotation thing, that somehow the current does constantly rotate. It takes one circular rotation around the conductor as it, for whatever length it is. So its entire trip will be one loop around the conductor. And that's just a physical fact, that's the way it gets from one end to the other, is that it has a, like, the positive end is top and the bottom, the negative end is bottom focused or something, and so it has to get from that position to the bottom position, and in doing that the current now switches which polarization it creates. And that's probably enough. But it's all right there. I mean, it's this explains, in my opinion, magnetism. And again, so gravity is mixed polarization. Magnetism is the filtering of mixed polarization. And electricity is, again, just the idea of polarization again, where the current is just made of polarization, stuff moving in one direction with one polarization. Yeah. Yeah, then I'll get to alternating current and the difference in the fields it creates. Obviously, alternating current would just keep switching these polarizations. So, the magnetism just keeps switching back and forth in terms of head to tail. Yeah, so this isn't what I wanted, but I knew this was going to be a hard video. I knew it was going to be difficult. but I'm just, look, the real value here. I mean, people, I just don't. I'm just surprised that people aren't more. Yeah, that'll work. I mean, here you have all these explanations of your physical world that depend on stuff being told by empty space what to do. And then magical forces where something just magically attracts or magically repulses. This provides you with a physical mechanism, something where you can actually understand this is stuff hitting stuff, causing stuff to do stuff. And I think it's really easy to understand. I mean, it's 1 plus 1, 0 plus 2. 1 plus 1 equals 0 plus 2. I mean, you can understand that something, if you combine something that's twice as effective and 0 effective, it equals the same as stuff that's 1 plus 1 effective. Yeah, I mean, this isn't. Okay, anyway. This explains physical reality. It doesn't rely on any. You don't need to understand any magic forces. All you have to understand is the idea of a bit, a quanta, of all universal size. It's all the same. Every single one of them is the same. Every single one of them has the same direction. Velocity. They all move the speed of light, and they all, and the only thing different about them is orientation. They're spheres with flying a frisbee flying this way or a frisbee flying this way. That's it. I mean, it gives you a simple diagram of the core of the universe, what it's made out of, and those are the only components necessary to create all this complexity once you understand this idea that things shadow each other. I mean, that's all that gravity, again, just understand, gravity is just a shadow. I mean, that's all that's happening is this stuff coming this way gets blocked by this thing, so there's less of it coming this way when it's gaining acceleration. So when it's gaining acceleration, it's eating direction this way and releasing direction in these other ways. I mean, it's so easy to understand. And vice versa, quite obviously. All this stuff doesn't get through this thing, so this thing gets less pressure in here. You just understand it as this less pressure rule, because these are all straight lines. Nothing can go around the corner. No bending around here to tell it what to do. No magic. I've already been over that part. Alright. So I'll concede this isn't exactly as good as I wanted it, so I'll have to just, like I said, I didn't think the conductor thing is the one that threw me a little. Because all I was thinking about is the idea that the conductor isn't as sensitive to the polarization isn't affecting it. It's causing polarization. So as gravity passes through it, it creates polarization. So there's just this distinction between a thing that's sensitive to polarization and a thing that can create polarization. So conductors, non-magnetic conductors, can create polarization, but they're not affected by polarization. And they're only affected by it once they have a field running through them, once they've been energized by a polarized movement, migration of electrons, technically, but it's not really the electrons aren't really moving, they're just passing quanta from one to another. And so the electrons at the end of the passage end up being very healthy, full of stuff. Anyway, but I'll get to that. Alright, I'll just leave this. I'll try again. I should be able to get some of this. Anyway, till next time.